Hey everyone, welcome back to Take You Forward. So today we will be solving the problem number of longest increasing subsequences. And this is the DP 47, the 47 lecture of the dynamic programming playlist. And yeah, the prerequisites to this problem is DP 41 and DP 42, which is based on LIS. So if you don't know LIS, please go back and watch it, and then you can just come back and watch this problem. So number of longest increasing subsequence. What does this mean? Now you must be knowing what is longest increasing subsequence till now. Now for this I can say the length of the longest is 4, and I can have something like 1, 3, 4, 7 as one of them, or I can have 1, 3, 5, 7 as another of them. So I can say the longest is of length 4. And how many subsequences are there? That's 2 subsequences. So I'm not concerned about the length because I know how to find the length. I'm more concerned about how many are there of length 4. And the answer to that is this is the first one and this is the second one. There are 2 subsequences of length 4. So that's the simple question. I will be giving you an array, and you need to tell me the number of longest, yes, the number of longest increasing subsequence. And over here it is 2. That's the question. So how do you solve this particular problem? So if you remember, how did we solve this problem? We used in DP42 we used a simple DP array, and we tried to fill that DP array using a couple of loops like this. If you remember well enough, I was going from 0 to n, J was going from 0 to I, and then you wrote this, and then you just change this. This DP was storing the length, if you remember well enough. But how do you have the count? That's my question. So let's take an example and try to see. So let's keep the DP over here. Let's maintain one more array, which is the count array. Okay, and now I'll teach you how to keep the count. It's very simple. So initially we are at 1. Okay, and it is itself, the length will be 1 because it is in this array, it is itself the longest increasing subsequence, thereby the length is 1. And how many of length 1 are there? That's very obvious. There's only one guy of length 1 for sure. So initially you start with 1 and 1 because everyone, please hear me out properly, everyone itself is an LIS, and so the count will be 1 and the length will be 1 as well. Perfect. Now let's move to the next guy, which is 5. Now when you are at 5, standing at 5, initially you say, hey, we will be 1 and 1 because 5 itself, remember this, 5 itself is of length 1 and it's a count of 1. But for 5, you look back, who is the previous? 1 is the previous. Can this 1 attach to 5? And the answer to that is yes. So if it can attach, the length will be 1 plus 1 because 5 has attached to 1. So 1 was initially having the length 1. So that gets attached to 5. So the length will increase. So the length will increase to 2. If the length increases to 2, I'm saying 1 gets attached to 5. So how many 1 did we have? The count was 1. So the count still stays as 1. Because if 1, there was 5. 1 came in and attached with 5. And 1, how many subsequences were there of length 1? 1. So thereby the length will increase to 2, but the count still stays as 1. Perfect. Next, you go to 4. This is where the understanding will start. So you go to 4. The moment you go to 4, you say 4 itself is of length 1 and 4 is having a count 1 because 4 itself is of length 1 and the count is 1, right? For 4, in this array, who can be attached? 1 can be attached to 4. Again, so the count will increase to 2 and 1 is only having a count of 1, so it stays. So you increase the length to 2 and the count still stays as 1. Next, you move to 3. The moment you move to 3, what do you observe? You say 3 is initially of length 1 and a count 1. But 3 can attach with 1 itself. Because 1 can attach with 3, 5 cannot, 4 cannot, because it's a longest increasing subsequence. So if 1 can, the length will increase to 2 and the count is 1. So you just increase the length to 2. So I can just erase all of these and write 2, 2, 2, and the count still stays as 1. Next you move to 2. This 2 in itself will have a 1 and 1. Now this 2 will attach 1 and become a longest increasing of length 2. Of length 2. So let's make it of length 2. But the count will still stay as 1 because it is of 1. So the count still stays as 1. Next you move to 6. All your focus back. Okay. Now the moment you move to 6, you ask who can attach it. So 6 initially will have a length 1 and a count 1. But that's for 6 itself. Now you look at the previous. This is the previous, this is the previous, this is the previous, this is the previous, this is the previous. Everyone is the previous. Can 1 go and attach to 6? The answer to that is yes. Yes, yes, yes. Thereby, you say, hey listen, the length will be 2. The length will be 2. And I can attach 1 with 6. And the length will be 2. Perfect. Next for 6, can you attach 5? The answer to that is yes. But still the length will be 2. But, you got, see, previously this 1 went in to attach with 6 and made a length of 2. So there was one guy of length 2. Now 5 came in, attached with 6 and is again of length 2. So can I say the count will increase to 2? The count will increase to 2 because 1 and 6 was there. Now 5 and 6 came. So the count will increase. If you're getting similar DP values, increase the count. Increase the count. Got it? Next. There is 4. Can 4 attach with 6? Yes. And if 4 attaches with 6, the length still stays as 2. And again you got one more count 2. So the length again is 2. So the count increases. I'm getting 3 guys of length 2 now. Again very obvious because 1, 6, 5, 6, 4, 6. All of length 2. Got it. Next. Can this 3 be a part of 6? Yes. I can still attach 3 with 6. Another length 2. So another count increase. Perfect. Can this 2 attach with 6? Yes. So 3 got attached with 6. Now 2 can attach with 6 as well. Another length 2 attached. So another count increase. The count becomes 5. So I can say, listen, what I can say. I can say at 6, there can be max of length 2 LIS. Which can be 1, 6, 5, 6, 4, 6, 3, 6, 2, 6. Anyone. So there are 5 LIS of length 2. There are 5 LIS of length 2 that ends at 6. Amazing, amazing. Let's move to the next. So I'll just erase this and I'll try to move to the next. We move to 7. Initially, 7 is itself of length 1 and count 1. Initially, 7 is itself of length 1 and count 1. Now I ask you a very straightforward question. For the 7, can this be a part? Yes, 1 can attach with 7. Yes, 1 can attach with 7. So if 1 attaches with 7, I can say this becomes length 2 and there is only 1. So count is still 1. Can 5 attach with 7? Yes. Yes. If 5 gets attached with 7, what will be the length? 5 getting attached means length 2, which means 1, 5 and 7. Because length 2 means 5 is already having 1. So 1, 5 and 7. So the length is 3. So the length comes out to be 3 now. And how many does 5 have? Count 1. So 1, 5, 7 goes. Next. 4. So I can say 4 is again having a length 2. So 4 means 1, 4. That can attach with 7. That can attach with 7. So another length 3. Another length 3. So this will go. So I got one more length 3. Prior to this, I got 1, 5, 7. Now I got 1, 4, 7. So the count increases to 2. Now I come to 3. Can 3 be a part? 1, 3, 7. Yes, it can be a part. So 3 is length 2. So 1, 3, 7 is again length 3. Which means count will increase. 1, 3, 7. Count will increase. Perfect. Next. You have 2. Can 2 be a part? Yes. 1, 2, 7. So 1, 2 means it had 2. So 2 plus 1 is 3. Again a length 3. So this increases to 4. So the count is increasing. If you are getting similar DP values, count keeps on increasing. Count keeps on increasing. And what count will you increase? You will just go on and add these values to this guy. You just keep on increasing the count. Perfect. Let's go on and see. If I am saying 6, I am saying 6. Okay. So can I have, now 2 is done. Can I have 6 as 7? I can. Very important point. Guys, please focus over here. Can I have 6 with 7? I can. 6 is saying I'm of length 2. But there are count 5s of length 2. Like I can have 1, 6, 7. I can have 5, 6, 7. I can have 4, 6, 7. I can have 3, 6, 7. I can have 2, 6, 7. So there are 5 guys that can attach with 6 and go to 7 to make a length of, I repeat, to make a length of 3. To make a length of 3. There can be 5 guys. So it can be 1, it can be 5, it can be 4, it can be 3, it can be 2. So there can be 5 guys. So there are 5 guys that can go on to have a length of 3. So 5 added, there can be now 9 guys of length 3. You realize there can be 9 guys of length 3. These are 4 and then there can be these 5. 9 guys of length 3. Perfect. This becomes 9 guys of length 3. Understood, guys? Very important, very easy. Because 6 was saying I'm a length 2, which means 1, 6, 5, 6, 4, 6, 3, 6, 2, 6. 5 guys were there. Now if 6 attaches with 7, those 5 guys will attach with 7 as well. So thereby this increases to 9. Perfect. Let's go to 10. 10. To whom 10 can be a part of? Let's ask. Can the 10 initially is 1, 1 definitely. Before that, let's erase this. 10 initially is 1, 1. Can this be 1 be a part of 10? Yes. So length will be 2 and the count still stays. Can this 5 be a part of 10? Yes. This is 2, so this will be 3. And the count still stays as 1 because it's 1. Can this 4 be a part of 10? Yes. So 2, 3. So this increases. The count will increase. Similarly, you can go on increasing, and you will eventually get your answer. So the basic stuff is very straightforward. Now, if I go back to the code, this was the code. If you remember, this was the code, right? So I'll try to say what are we specifically doing. What am I doing? Ask the question. Like, let's ask the question. What am I doing? As of now, I was just updating the DP, right? So whenever there is an increase, I will say, I will take the count for I from count of j, because in the number of ways I can make j is the same ways in which I can make count I. If this is greater, this is greater. So the number of ways in which I can make j is the number of ways, because I just add I to it. That's it. But I'll just add one more condition to here. Else if, very important, else if array of I greater than array of j and dp of j plus 1 is equal to d, like what if it's equal, then I will say, okay, this will, dp will still have the same value, but it will take, how many ways can count j be formed? Just take it. If you carefully see, this was the case. There's 5 ways, you ended up adding it over here. So in how many ways can it be? You just take it and you add it over here. And at the end of the day, you can just figure out the maximal value of LIS and you can just add up the count. That will be indeed your answer. So you have pretty much got the idea. So what I'll do is, I'll just take this smaller example to quickly show you how will you get the answer. 1, 3, it was 5, 4, 7. And we knew that 1, 3, 4, 7 can be an answer, as well as 1, 3, 5 and 7 can be an answer as well. So we definitely knew that. So what I'll do is, I will just keep the DP and I'll just keep the count. So initially this is 1 and 1. Now this, everything will be initially filled with 1 and 1. Perfect. Now let's come back. So we are here. That's done. Next we'll go here. So 3 we'll see this one is a potential and it's having a 1. So I'll just increase this to 2, and whatever is here, I'll just copy paste. So this is 1. Perfect. Now I'll go to 5. When I go to 5, I say, hey listen, this 5 is having 1. Can this 1 be a part of this 5? Yes. So this 1 will go up and make it 2. And this 1 will be replicated. Perfect. Now, this 3, can it be a part of 5? Yes. So the length will be 2 plus 1 equal to 3. And this 1 will be replicated because there is only 1, 3, 5. Next, you go here. That's 4. Can this 1 be a part of 4? Yes. So this 1 replicates it to 2. And this will be copied. Can this 3 be a part of 4? Yes. So I'll say, okay, if this is 2, this can be 3. And this will be replicated. Can this 5 be a part of 4? No, because longest increasing does not allow you. Next, go to 7. Next, go to 7. The moment you go to 7, you have 1. So you see 1. Can you be a part of 7? He says yes. So I'll make it 2. And there's only 1 7. Can this 3 be a part of 7? I'll say yes. So this 2 will go and make it 3. So this is as of now 3. And the 1 is copied. On this 5 is when you understand. This is a 3. So 1, 3, 5 and 7. Can it be? Yes. So this 3 will go and make it 4. So I'll make it 4. And I'll still copy paste this one. Now, can this 4 be a part of 7? Yes. But this is 3. And if I add it, it will still be 4. So you got another 4. So take this one and you're saying another. So 1 plus 1 is 2. So you make it 2. At the end of the day, where is your alias located? The alias is located here. Is there any other 4? There can be any other 4. Like assume there was a 4 here. Assume there was a 4 here. Then you would have taken this plus this to say there are 3 subsequences. But since there is only 1 4 and it says 2, so you say 2 subsequences. I hope I was able to make you understand. Now it's time that I go back and try to code this up. So it's time to check out the code. So what I'll do is I'll just go across and copy paste the alias code because I'm not interested to write so much. Let's copy paste the alias code, and I'll also copy paste the hash include. Okay, perfect. So what do I require? I require a count. So you can keep a count as n comma 1. That is something which we will do. Okay, so we can ignore this maxi. You can also ignore this maxi. Okay, perfect. Now what have I told you? If this is the case, it's like it is definitely perfect. And I will say I'll just inherit the count which the new guy gives you. But if by chance the array of previous is smaller than array of I, okay, and the DP comes out to be equal, that is very very important, that the DP has to come out to be equal. Like 1 plus DP of previous, like you got another guy who still gives you the same value. You got another guy who says you that, hey listen, I'm also the same subsequence. So you say, okay fine, you're the same subsequence now. There's no need to update the DP. So what I'll do is I'll just take you into myself. This says he's new, so just inherit. This means inherit. Don't add because it's new. Inherit. But this means, okay, I got someone with the same length, so increase the count. That's how you increase. Once you've done with this, probably you can figure out the alias length over here. You can say maxi equal to max of maxi comma DP of I. Figure out the alias length. Once you have figured out the alias length, very important. So just go across the count array, and that will be answer. Like whoever is giving you the same length of alias, whoever, like if DP of I is equal to maxi, you say count, or this will be probably numbers, something like this. So you say numbers of alias will be count of i's. So all the aliases will be added, and once you have added all the aliases, you can just return the nums, and that will be your answer. So that's the subtle change in the alias code. If you do, you should be able to solve this problem. Okay, so n is definitely not declared, so let's declare the n. It should be fine. Apart from this, there will be previous over here again. My bad. Let's keep it previous. Okay, perfect. Now should be fine. So yeah, folks, with this we will be wrapping up the LIS pattern. And yeah, in the comment section as usual, tell me now if you can solve all the problems related to LIS pattern and if you've understood it or not, because it does give me a very good feeling when you tell me that okay, this pattern has been completed. Now I'm very comfortable on this pattern. So just make sure, just take out your 5 seconds, 10 seconds to drop out a comment, and yeah, like this video. And if you're new to this channel, please do consider subscribing to us. So yeah, with this I'll be wrapping up this video, and in the next video we will be starting off with the MCM pattern. Till then, bye bye, take care, good night.